Hello, my name is Leonie Disch. On behalf of myself and my co-authors Fessl and Viktoria Pammer-Schindler, I present the paper Designing for Knowledge Construction to Facilitate the Uptake of Open Science, laying out the design space. The motivation of our research was to study and inform design that facilitates the uptake of open science resources. Open science has become increasingly important as scientific knowledge is crucial for societal and economic growth. Open science resources can be benefited from if the information is understood and integrated into existing knowledge. Our goal was to find out how technology design can support knowledge construction and how this technology design is applicable to open science platforms. Therefore, to lay out a design space for open science platforms in particular. Our methodology consists of two major parts: an analysis of literature and a synthesis of literature into design implications for open science. In the first part, we have summarized existing literature on knowledge construction and synthesized it into a combined model as a theoretical background for our work. Next, we analyzed design-oriented literature to explore how technology design can support knowledge construction. To find literature, we conducted search processes on Google Scholar and ACM. From the retrieved paper of the searches, we extracted design heuristics. By design heuristics, we understand guidelines on how knowledge construction can be designed for. In the second part, our goal was to develop these heuristics into a design space for supporting knowledge construction in open science. We grouped the heuristics into design categories. The categories are useful for moving beyond the heuristics towards a larger space of technological functionalities. In parallel, we reviewed popular open science platforms and identified their common core components. We then mapped the design heuristics onto these core components. This mapping results in a set of design implications, by which we mean suggestions for the design of knowledge construction in open science platforms. What is knowledge construction? Knowledge construction is described as a process of constructing new knowledge based on prior knowledge. It is understood as an individual cognitive or collaborative social process. The social and cognitive systems are mutually dependent and enrich each other through information externalization and internalization. Our combined model of knowledge construction brings together models that specify the different levels of individual and collaborative knowledge construction. To construct new knowledge individually, one must process new information. The new information must be reflected, consolidated, and integrated into prior knowledge concepts. Collaborative knowledge construction happens through externalization of information, the dissonance of ideas, integration and co-construction of ideas, and building a consensus, resulting in newly collaboratively created knowledge. By analyzing design-oriented literature, we found that 6 different design heuristics supported individual knowledge construction in different online environments. For example, to offer concept maps that recommend associated concepts, assist in linking concepts, and the visualization of expected learning outcomes in the form of concept maps. Collaborative knowledge construction is supported by 10 design heuristics, such as offering predefined guidance, steps, and collaboration guidelines. 10 different design heuristics supported both individual and collaborative knowledge construction. For example, the recommendation of related concepts, arguments, definitions, or further theoretical knowledge. We developed 3 design categories into which these design heuristics fall. Design category 1, structuring and supporting collaboration. Design category 2, supporting the learning process. And design category 3, structuring, visualizing, and navigating learning content. We then mapped the underlying functionalities and actions of heuristics to the categories and their overlaps. Design category 1 subsumes interactions such as guiding, supporting, and visualizing collaboration and communication. Design category 2 is dedicated to enriching the learning process with additional knowledge, materials, and information. Design category 3 contains functionalities for visualizing information and thus making this content more understandable and accessible. The final step is systemizing how these existing design knowledge could be used in open science platforms to facilitate knowledge construction. As there are already existing open science platforms, the question arises, to which of their components could functionalities for supporting knowledge construction be attached? For that, we identified the core components of popular open science platforms and found that most platforms have the functionality of searching and reading scientific content. Other common core components were usage and impact matrices, social networking, discussion forums, and content curation. In the next step, we took these common components and mapped the design heuristics that support knowledge construction and their categories onto these common components of open science platforms. We have further developed this mapping into design implications, especially for open science. The design implications are based on knowledge construction theory, evidence about designing for knowledge construction in other contexts, and knowledge about typical open science platforms. We further give examples of how these design implications can be integrated into open science platforms. An implication for open science is, for example, collaborative visualization, with graph visualizations to show the connections of different users in the network. Our conclusion and takeaway message is that this mapping and the implications constitute a design space for open science. It informs researchers and designers in the human-computer interaction community. There you find suitable functionalities for supporting knowledge construction that could be implemented into existing or new open science platforms. Thank you for your attention.